In this video, we're going to look at addition and subtraction in bases other than base 10. And then hopefully as you reason through these ideas using unfamiliar bases, that's going to help you to understand and be able to explain better the base 10 numbers that you're going to use with your students. So if you need some extra explanation when we finish this, G'day Math has an addition video and a subtraction video, and that will be posted in the PowerPoint section of Blackboard. Also, I have two videos in the content section that I created a couple years ago, one on addition and one on subtraction in base 5. Those are not in the Edpuzzle video section, they're just in the content section because these are not required, they're just there as an extra resource if you need them. Okay, so let's consider base 5 first. I have 1, 2, 12 base 5, and 3, 1, 31 base 5. And what I'm doing is I'm adding them. So the model that I have here, I have 12 in this one, I have 31 in this one, and I'm going to combine them together to see what the sum is going to be. So 1, 2 in base 5. All right, let's look at what we have here. I have two tinies, which you can see right there, and I have one long, which you can see from right here. The difference between this and what we usually work with is that our one long has 5 blocks in it because I'm working in a base 5 system. Anytime you have 5, remember there is no digit 5 in the base 5 system. So anytime you get to 5, you have to bundle up to the next place value. So 3, 1, 31 in base 5, that's going to be 3 longs and 1 tiny. And you can see that right here. Again, all of my longs have 5 blocks in them. So when I combine them, 1, 2, 3 tinies I can put together. Well, that's okay. I'm allowed any digit between 0 and 4, so 3 is fine. And then 1, 2, 3, 4 longs, and again, 4 is fine. So my answer, 4 longs and 3 tinies, that makes 43 in base 5. All right, let's do another one. So this time we're going to do 14 in base 5, 1, 4, and I'm going to combine that with 33 base 5, 3, 3. Okay, so one thing I want you to notice about this is when we are adding, I model both numbers. Here's the 1, 4, the 14 base 5, and here's 3, 3, the 33 base 5. I model both numbers, and then I'm going to combine them, and what I have at the end is my answer. Okay, so let's combine all our tinies first, just like we're used to doing in the standard algorithm. And I can see that I have more than 4 here, which I'm not allowed to have. Remember, anytime I have 5, I have to bundle up and go to the next place value. So I'm going to group 5 of them together, and that's going to become 1 long with 2 tinies left over. So what I have over here is 2 tinies, and I carried 1 long to join with the other longs. Okay, so let's put our longs together. 1, 2, 3, 4. Uh-oh, I've got to go up to the next place value. So I'm going to combine all my longs. And remember, when I put a group of longs together, what I end up with is a flat. So it takes 5 longs to make a flat in base 5, just like it took 5 tinies to make a long. It's going to take 5 longs to make a flat. And so you can see here I have 1 flat. So I have 0 rods and 1 flat. So the answer to 14 in base 5 plus 33 in base 5 is 102 in base 5. 102 base 5 is what I have modeled here with the blocks. 1 flat, 0 longs, and 2 tinies. Okay, let's look at this one. So I've got 1, 4, 14 in base 7, and I've got 3, 3 in base 7, but I notice a difference here. This time, how many blocks are in my long? Well, it's a base 7 system, so it takes 7 tinies to make a long. 1, 2, 3, 4, 5, 6, 7. Okay, so let's start off by combining our tinies, and I can see right away that I'm going to have enough to bundle up the next place value. So I'm going to go ahead and put these together, bundling up to the next place value. Okay, so what happened over here? Well, now I have 0 tinies, and I've carried 1 long over to the next place value. And now in that I have 1, 2, 3, 4, 5, which is fine. It takes 7 to bundle up to a flat. I don't have enough to make a flat, so I have 5 longs. So my answer there is 5050 base 7. So pretend that 7 right there was just a little bit lower. Unfortunately, I can't get it to type down there. Okay, let's look at this one. So this time I'm subtracting. Notice the difference in the setup. When I'm subtracting, I only modeled the top number. So I've got 34, 3, 4, back to base 5 again. So I have 5 tinies and a long. And I'm going to remove 13 base 5. I'm going to remove 1 long and 3 tinies. And I'm going to do it exactly the same way as we would expect in the standard algorithm. I'm going to start in the ones place. And I'm just going to move them off to the side of my desk just like I was a small child learning to subtract. I'm going to remove 3 of them, and I can see that I have 1 tiny left. All right, so now let's look at the longs. I had 3, and I need to remove 1 of them, so you can see that I have 2 left. So my answer to 34 base 5 minus 13 base 5 is 21 base 5. 21 base 5 is the answer to this question because that's what I have left on my blocks. All right, let's do this one. So I've got 32 base 5, 3, 2, 3 longs and 2 tinies, and I'm going to remove 14 base 5, 1 long and 4 tinies. Well, immediately I notice I only have 2 tinies, but I'm supposed to remove 4. So be really careful about how you explain this to your students. You do not want to tell them you cannot take 4 away from 2, because that's a big fat lie. You can take 4 away from 2, you just get a negative number. So if you are a second grade teacher teaching regrouping and you teach it that way, your students are really going to struggle when they get to 7th grade and their 7th grade teacher says 2 minus 4 is negative 2. Well, you've been telling them that that cannot be done, and now all of a sudden it can be done. So be really careful about the phrasing that you choose to use. It seems small, but it has big consequences. It is okay to say, look, I have only 2 tinies and I need to remove 4 tinies, so I need some more tinies. That's a true statement because I'm looking at a physical model. That's a lot different than the abstract, you cannot take 4 away from 2. It's also okay just to point out, do you guys notice that the 2 in the top number is smaller than the 4 in the bottom number? Well, when that happens, I need to regroup. That's a true statement also. And that's exactly what we're going to do. So this one group of 5, I'm going to split it up into 5 tinies. Oops, that one got hidden. Okay, let's look at what happened here. So I had 3 longs and one of them is gone. So now I have 2 longs. Let's count in base 5 and see how many blocks I have left. 1, 2, 3, 4, 10, 11, 12, right? Because there's no 5. 1, 2, 3, 4, 10, 11, 12. So I have 12 tinies in base 5. And I'm going to remove 4 of them. 1, 2, 3, 4. All right, and so what I have left is 3 tinies. Now I had 2 longs after I regrouped. I had 2 longs and I need to remove 1 of them. And I have 1 remaining. So 32 base 5, 32 base 5 minus 14 base 5, 14 base 5 equals 13 base 5 or 13 base 5. Notice the similarity with what you're used to seeing with our number system. Okay, let's try this one. So I'm moving from base 5 to base 3. So how many tinies does it take to make a long? If you said 3, you are correct. In a base 3 system, it takes 3 tinies to make a long. And you can see here I have 2 longs and no tinies, which is what this number represents. I want to remove 2 tinies. Well, I need to put some tinies over there. So let's regroup. All right, look at what you have here. Counting in base 2, Remember, counting in base 3. Remember, there's no digit 3. 1, 2, 10. So when I regroup over here, I took one of my longs, and I now have 10 tinies. All right, let's take away 2 tinies. And what I have left is 1 tiny and 1 long. So 11 base 3, 1 base 3 is what you have when you take away 2 base 3 from 20 base 3. All right, let's move to base 8. So in base 8, how many tinies does it take to make a long? It takes 8, right? You can see my 8 tinies put together right there to make a long. I've got 4, 6, and I'm going to remove 24. So starting in the ones place, I'm going to remove 4, 1, 2, 3, 4. All right, no problems there. And now I'm going to remove 2 longs, 1, 2. And so what I have remaining, 2 tinies and 2 longs. 46 base 8 minus 24 base 8 is 22 base 8. 2 longs and 2 tinies. All right, let's try this one. We're going to start off the same way, 46 base 8. So how many tinies should be in a long? Right, I should have 8. So you can see here I've got 46 in base 8, and I want to remove 27. Well, I don't have enough tinies here, so let's regroup from this one. 1, 2, 3, 4, oops, that one disappeared. 4, 5, 6, 7, 8. All right, so now let's count how many we actually have here in base 8. 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, 14, 15, 16. So I have 16 tinies and 3 longs. Okay, now let's see if we can remove 27. Let's start off by removing 7 tinies. 1, 2, 3, 4, 5, 6, 7. And what I have left, 1, 2, 3, 4, 5, 6, 7. So I have 7 tinies. And then for my longs, I had 3 right there after I regrouped, right? And I want to remove 2. 1, 2. And so I have 1 long remaining. So 46 in base 8, 46 base 8, minus 27 in base 8, 27 base 8, gives me 17 base 8, 17 base 8, which I can see there as the answer in my block.